In the previous video, we were asked to calculate the percentage return per annum with semi-annual compounding, given that an investor receives $1,100 in 1 year in return for an investment of $1,000 at time 0. And what's different now is that we are asked to calculate the percentage return per annum with continuous compounding instead of semi-annual compounding. And this makes it a slightly different animal, because what we knew, our starting point is the discrete compounding formula. So we know that if we multiply the initial value by 1 plus the rate of return divided by the number of compounding periods to the power of the number of compounding periods, that gives us the final value. However, when it comes to continuous compounding, this guy tends to infinity, m tends to infinity. So the way we can rewrite this expression is initial value times the limit as m approaches infinity of 1 plus r over m to the power of m. That is always equal to our final value. And without proving it here, we know that there's an identity such that this guy here can be rewritten as e to the power of r. So basically we can multiply the initial value times e to the power of r and get the final value with continuous compounding. So now that we know that, we need to solve for r, and let's see how we can do that. We can certainly start by dividing both sides by the initial value and be left with e to the power of r equal to final value over initial value. And if we want to isolate r, we can take the inverse function of the exponential function. So take ln of e to the r and ln of final value over initial value, and we end up being left with r equal to the natural logarithm of the final value over the initial value. And when we plug the numbers in, we have the ln of $1,100 over $1,000.